Now, already, I believe in mice, you can take a germ cell from a mouse, I think from their bone
From
marrow,
the skin.
from the skin,
Yeah, they can
and
make a
grow
sperm
it into a sperm or
and
grow them into
egg.
eggs.
Yeah.
Whoa. Hello. Welcome to the Dr. Gil Show. This is where we talk about medical matters that matter to you. My guest today is Dr. Anil Dubey. Welcome to the show, Anil.
Thank you for having me.
Anil, PhD, is my IVF lab director. He's coming up on 10 years
Yes.
working with us.
Mhm.
Not only does he run our IVF lab, but he's become a dear friend over the years. And I've really been looking forward to talking to you, Anil, about in vitro fertilization.
It's my pleasure.
Now, in vitro fertilization, we call IVF, started back in the 50s. They were able to do it in rabbits, but human beings were horribly difficult for many reasons to be successful with. In Cambridge University, there was a Dr. Robert Edwards and an OBGYN doctor named Patrick Steptoe
Yes.
who worked together in the 50s and 60s, particularly in the 60s, and were finally able to get in vitro fertilization to be successful. And the first baby born from IVF was Louise Brown, born in July 25, 1978.
That's correct.
Edwards and Steptoe and a lot of collaborators worked in Cambridge for many years. And after 300 attempts at trying to retrieve an egg from a woman, to fertilize it in the lab, make an embryo, to transfer the embryo back into a woman's uterus and to be successful. It took about 300 attempts, give or take. Now, what's really special about your training, Anil, is you got your PhD in Mumbai in '79, but then you worked in Cambridge in England in from 1980 to 82, when IVF was just getting off the ground, just getting started. And for those that don't know, Cambridge is like the Harvard of England. The Cambridge and Oxford is like Harvard and Stanford, the top premier places. And there you were in the early 80s when IVF was just getting going. So tell me about your time in the early 80s in Cambridge working with Dr. Edwards.
Well, thank you, Dr. Gil Wilshire, my friend. And it's amazing 10 years working with you, especially the way you care for the patient, you take them to the next step, and we all try to give a bundle of joy to them.
Yes.
And it's amazing experience. In my journey, all this year, it's truly, I'm blessed. And it's I mean, nothing else I would be doing if I would not be in this field. That is most amazing field. So my training back home in India was in reproductive physiology. That's where my field was. How the gonad in utero differentiate from male to female. Um, you know, and that's how my interest started in reproductive physiology.
So Dr. Edwards in particular was researching physiology. How do eggs work? How does sperm work? How do embryos grow and all that kind of stuff?
That's correct.
So they had all this early basic science research, which was the foundation of IVF. So clearly you were an excellent candidate. They must have liked you. They brought you to your postdoc at Cambridge. And then what did you see? What was it like? I'll add another piece of history. There was a lot of resistance to IVF from the establishment, from the public, from the press. There were a lot of prominent professors and department chairs that said they were working with the devil doing IVF, there was a lot of pushback and resistance as Edwards and Steptoe were doing their work. And I believe it took a while for that resistance to subside as successes and accomplishments were being made. So what was it like doing your postdoc in Cambridge in the early 80s?
It was, with any new field, there's always was a resistance, will be resistance, until we prove that it's ultimately beneficial to the humankind.
Oh, you had to prove yourself.
Yeah, and the IVF field since last 30 years, 35 years has really evolved so much.
Oh,
Right from the basics, just not producing test tube babies in the lab and then wait for the result. The success rate was very, very low in
yeah.
comparison to today. When I started working in Boston in 88, 89,
Uh-huh.
we were just looking for high 10 to 15% pregnancy rate.
Right.
And
So
now
you were at
look at-
Tufts in Boston,
Yeah,
a very good program with some of the best people in the
Yeah.
country. And when I trained in 1992, a good success rate was about 12%.
that give and take.
Give or
and
take, yeah. It was like when
So-
if you got a hit occasionally, you were doing a good job.
But it was all due to the hard work of Bob. Bob, I had like first name basis relationship with him. Such a kind gentleman, English gentleman with humility. Um, it was amazing experience. They will work, and work. I mean, you got to be there. It's like 14 to 16 hours of work. The research. I mean,
In a stretch.
Yeah,
And if ovulation happens in the middle of the night,
they
you're
were
up.
doing it. So
You're up.
yeah. So we were all, at that early days, we were working with a natural cycle. A natural cycle is there's no hormones given at that time. We had to measure the hormones like every 6 hours.
Yeah.
Go like 2 a.m. in the morning to the lab, try to get the egg, hit and miss. But mostly we will get egg. And then there was an issue with, culturing embryo because the commercially available media where we grow these embryos were not available those days. We
Yeah.
have to make our own media with our own recipes.
Right.
Of course, they were sharing the knowledge with, French people, English laboratories. It
Right.
was amazing at that time. And again, the knowledge is for spreading, sharing,
There was a lot of
and
good-
that's
yeah.
how the success comes.
Everybody helped, and eventually Australia got into the mix. People all
That's
over the
true.
world started
Yes.
working
You're
on
right.
this.
You're right about that. Yes.
So you got to work with Bob Edwards. Now,
Yeah.
Bob Edwards got the Nobel Prize in Medicine and Physiology in 2010.
Yeah.
The Nobel Prize only goes to people who are living. So Dr. Steptoe had passed away, and he didn't get a Nobel Prize because he had passed away.
Yeah.
So you were working with a Nobel Prize laureate to be,
Yes.
and you were in the early phases of IVF. So let me explain for our audience here that to get an egg out of a human being is very difficult. It has to be sucked out of the body with surgery and a needle.
Those days, yes.
And you have to be there's a particular window. There's only a few hours where it's available
Absolutely.
because it's going to pop.
Mm-hmm.
So you have to get it while it's in there and mature, but before it pops, you've got these fine windows. Then when the egg comes out of the body, light will kill it. Anything but body temperature will kill it.
Mm-hmm.
The pH is wrong, too much oxygen, too little oxygen. Very finicky.
Yeah.
Getting the sperm to fertilize the egg. Very finicky. Having it in these liquids, they're called media.
Yeah.
And all these ingredients in the media, like you were discovering, they didn't know what was the best.
Yeah.
Media have been evolving. And then how to get the egg from the human. Now tell me, I believe this is a true story. Dr. Steptoe would retrieve the egg from a woman in his hospital.
Mm-hmm. Yes.
I think Bob Edwards or somebody had it in a test tube, would drop trowel, tape the test tube to their thigh, tape it there, and pull their pants back on to keep it warm. Go down in the tube, go down in the subway, and go a few stops down the road to get to the lab to make the embryo. Which took 3 days.
It's
Isn't that
amazing story.
I mean, we have incubators now. We can wheel them around. He taped it on his thigh.
Yes.
Right? So you make it, then how do you get it back in the uterus? So all these technical things were being worked out when you were doing your postdoc.
So similarly for freezing embryos now, it's so easy to do it than those days. It was so difficult. We had to just rely on the information and research from the bovine industry.
Yeah, bovine for animal. We use animal information and try to apply it to
implement it.
But it's not the same, is it? Exactly.
No, not the same. Now the freezing and survival rate of embryos is close to 90%. Earlier days, it was roughly around 10 to 20%, if we freeze it correctly.
Yeah, so people need to understand, if we have created some embryos, or we've taken some eggs or some sperm, we can't use it all right then. We need to find a recipient who's ready. We've got all these eggs, maybe some embryos. We have to be able to freeze them.
Yeah.
And that technology has advanced leaps and bounds during your career.
Leaps and bounds. Yeah.
And I believe the Japanese have helped us with that.
Yeah, tremendously.
Tremendously.
I think it's an international community.
It's an international effort.
International efforts, no boundaries for sharing knowledge, and that should be for every field. And so it's true for IVF.
It's true. Yes,
so
it is.
When Bob and Stepto got their Nobel Prize, it's just not for the IVF, but the utilization of this technology to stem cell research, to genetic analysis, to surrogacy, egg freezing, all of this is based on 40, 50 years of knowledge.
Yeah. I think people think IVF is just for people who are just having trouble getting pregnant. No. 2 or 3 times a month, Anil, I have a young man or woman with cancer who is about to get chemotherapy or radiation.
Yeah.
And we only have this small, short window to save their eggs or save their sperm before they are possibly rendered sterile from a treatment. So this has ramifications all over medicine and in the healthcare of people. So after Cambridge, you came to the United States and worked at a very famous lab in Pittsburgh that had been started by Dr. Richard Nobile. Dr. Nobile actually trained, I believe, Dr. Weiss, who was the chairman of my fellowship.
Gerson Weiss.
A very Gerson Weiss, very famous man who I trained with for a few years. And so that was your entree into the United States. You continue to watch this field develop. Success rates keep getting better. Then you end up going to Boston at Tufts and work with Dr. Alan DeCherney, one of the biggest, I would say, rock stars in our field.
That is correct.
Who is now has been the division chair at NIH of endocrinology, etc. So you've worked with some of the biggest people in the field, Anil, during your training and your years here in the United States. Something happened in 1994. You were integral in the development of a way to fertilize the egg more dependably. Because IVF was originally developed for women with blocked fallopian tubes.
Correct.
If a woman doesn't have blocked fallopian tubes and the gentleman has low sperm numbers, we have a male factor. So tell me, how are you involved in overcoming male factor in the world of IVF and infertility?
Yeah, so it's very interesting topic you got. It's male infertility. Earlier it was taboo that if the couple is not having child, then it's the problem with the female partner.
Right, they assume it's the woman's problem.
Always it was women's
problem.
But
it's mistake.
Not. It's not. It's it is almost like 50-50.
It's all nowadays. It's almost 50-50.
So earlier time we were struggling with this technology. how to maximize chance of fertilization where we have a poor or no sperm or getting a sperm
Yeah.
from the testis.
Let me dispel another myth. People say, "Oh, it takes just one sperm to fertilize it."
Correct.
No, it takes thousands of sperm
Yes,
attacking an egg
naturally.
to get one sperm in the egg with natural fertilization. It takes thousands, doesn't it?
So this technique is called intracytoplasmic sperm injection, ICSI.
Okay.
That's the short form of that. Was developed in Belgium, and I got trained there by Andre van Strategem, who was the father of this.
Oh my goodness,
and
you were there too. You went to Belgium to learn ICSI and develop the ICSI procedure.
Yeah, so then after that couple of years I worked, and then we had first workshop at Boston at Tufts University, together with my clinical colleagues, Dr. Ellen Ducherney, Reindaller.
Richard Reindahl. Yeah, for those of you out there, that these names don't mean much to you, but it's like Mick Jagger and David Bowie right there, right?
That's true. That is
wow.
True. So all this years of my career, I was in academic settings, like working in the university, teaching students, resident training, and the fellowship training. That it's required to have a specialized training for clinicians. Sure. And also they should spend some time in the lab. So they, I opened the lab door for them, and it was a fantastic journey, right, in the academic setting.
Yeah. The training, my fellowship training is in reproductive endocrinology and infertility. And back in the, in the 70s, there wasn't a fellowship for this. If you needed endocrine, you'd have to go to an endocrine department somewhere, and then maybe go to a urology department over here and try to mix and match. And eventually it came together as a specialty.
Correct.
Called reproductive endocrinology. And then infertility was added. There's a whole story behind that. But our field has been evolving and getting more sophisticated. And to have a certified, accredited IVF program, I need a medical director.
Yeah.
I need a clinical director, and I need a lab director. And someone said, and although some people do all three, it's much better to have a lab director who has a PhD and another degree, Anil, called HCLD. What is an HCLD, Anil?
So this is it's a high complexity laboratory director. So it's like a certification. You take a courses, and then you get certified by American Association of Bioanalysts, and you have to keep continuing education. You have to accrue those hours all this year to be active as a lab director. So that required not only for embryology part of it, then also andrology, like a sperm field, sperm and egg, and also the general, general category of how, quality control, quality assurance, how to keep the equipment working properly, how to have
the whole lab. Lab is its own world, Anil.
Correct.
And that's where you need an expert like you to supervise it. Once again, so I'm so grateful that you work with us. So we've seen the development of IVF go from hit or miss, not knowing what's going to work, requiring some luck, to a process now. It's an incredible success.
It is.
Last month we did something like 20 embryo transfers. Every woman got pregnant last month, Anil. Now some have started to miscarry. It's not 100% take-home baby rate, but to go from hit or miss when you and I first started training, to something where not just the majority, but the vast majority of people are successful, is just an incredible thing to see in our careers, isn't it?
Mhm.
In our lifetime.
Absolutely. The technology is there. Technology, and it is for everyone to be utilized. The attempt, you may not be successful in one attempt, but there's sure if, it's all just tricking the treatment will ultimately give you the results.
Yeah. If we have a good egg from somewhere,
Yeah.
a good sperm from somewhere, and make a good embryo from that, and get a good uterus from somewhere, and get those three together, generally the success rates are gonna work.
The most important part is just the implantation part. Now we are all over the country, all the labs, they're so good.
Yeah.
There's no one lab is bad or
Yeah,
the best.
the
They are
quality
all.
and success rates are. It's like a rising tide is raising all ships, isn't it? We all go to the same conferences, we read the same papers, and everyone's getting better. And I've got to say, the spirit of collegiality and sharing and teamwork in our field is just fantastic. I cannot recall ever that someone has found a breakthrough or an improvement in their lab that they haven't been glad to share, at a conference or a phone call or what have you, or in a paper. Everyone is so willing to share their advances because honestly, there's enough work for everybody, isn't there?
Yeah, that is true. That is true. There are some stories like some, which gives some bad praise for us.
Sure, yeah, there have been some bad apples and
there's
some bad stories.
but that's quite, there are few and far in between.
And far in between, yes.
But overall, once you're in a program, you're in good hands.
Yeah, generally. And there was some newspaper article in the past, or the reporter said, "Oh, IVF, in vitro fertilization, advanced reproductive technology is the wild west of medicine," as if we were running rampant, guns blazing, no ethics. Nothing could be farther from the truth, could it, Anil?
Correct. This is not true. I mean, we are all being watched, being certified,
right?
And we are using the quality products. We do miracles, but not 100%. It's we try.
But we have very high ethical standards.
Very much so.
We're inspected up the yin yang.
Very much so.
People can come in at any time. People don't realize that the FDA inspector, and by the way, FDA inspectors wear military type uniforms. That the history, let me share with you, is that the FDA needed to get onto ships.
Yes.
Coming into the country to inspect ships and whatnot. Yeah. And a person coming in a suit and tie or overalls didn't get on the ship. So they found if they wore these admiral type naval uniforms, they could get where aye, sir.
Yeah.
And they were, so the COVID pandemic put a little kibosh on this. But in the good old days before COVID, anytime a person in one of these FDA naval suits would show up, you'd have to let them in.
Yes.
You'd have to give them a room and a desk, and they could inspect all your charts and check what you do.
Yeah, absolutely.
So we have seen an evolution of the ethics and the standards of care.
Yes.
Best practices.
Yes.
And from time to time, these are reevaluated and modernized and kept up to date by the leaders in our field. And I see your name from time to time on these committees. I remember the doctor who added infertility onto my certification. His name was Robert Rebar. It was called reproductive endocrinology, and he had them put infertility on that.
Yeah.
And successfully lobbied to give it the modern title that it is now. I think Robert's recently retired.
Yes.
So Anil, where do you see things going? obviously success rates continue to improve. The ability to use surrogates, for example, there's a number of clinics in California that have couples that the woman has a severe medical problem, doesn't have a uterus.
Correct.
Pregnancy would kill her. She's been losing her pregnancies. Sometimes they find some lovely, fertile, young Midwest women here and we'll help prepare them, and they'll fly to California for an embryo transfer and become a surrogate. Almost all the time they come back pregnant, we do their ultrasounds, and they're successful. So we're seeing more and more surrogacy so that older women, sicker women can have a biological family. What other developments do you see going on in NIL, maybe in genetic testing?
Oh, absolutely. I'm coming to that. But the women, the surrogate mothers really are out there and helping this.
Oh, they have big hearts and they'll.
Big heart.
I mean, they are compensated.
They are, but that's the compensation is not everything.
It's not everything.
It takes a very special person to be a surrogate.
It really does. And they're
to give that child back to.
And then to give it up to knowing what part you played. Yeah.
It is. You know.
I have yet to meet a surrogate that did it for the money.
Yeah.
I mean, obviously, you got to pay for your gas, and you're going to pay for your plane tickets and your health insurance and whatnot.
No, they are putting their life out there.
They are putting
their life on hold for 9 months for somebody. You know, it's just, as you said, it's just not for the money. It takes a special person.
It's an incredible gift.
Yeah. So coming back to your question about the genetics, yes.
Tell us about the genetic testing, which has revolutionized reproduction.
Yeah, it is. It just started with simply just knowing the chromosome complement of an embryo, where we can biopsy few cells from developing embryo and then freeze the remaining embryo, and then analyze for chromosome for just simple, 23 pairs.
Yeah, and let me explain this too. You get 23 chromosomes from your mommy. You get 23 chromosomes from your daddy. And that has to be perfect.
Yes.
And you have to have them come together. So they need to. The mom and dad need to pull these chromosomes apart perfectly. They have to come back together perfectly.
Correct.
And 2 to the 23. I mean, it's an enormous number. There's so many places for error.
Yes.
And in fact, as a rule of thumb, half of the good-looking, beautiful embryos we see in the IVF lab, roughly half of them have abnormal chromosomes.
That is correct.
And are incompatible with life. It's just
astounding. It is astounding.
They never would have. Well, maybe they didn't, but I don't think they were thinking that back in the 1960s and 70s.
No.
It was unknown.
It was unknown. So genetic field, I mean, it's really exploded.
Yeah, so I know you've got affiliations and with various labs, and you know a lot of these technologies. Tell us a little bit about these technologies, so we can biopsy an embryo now, or you and your embryologist can biopsy an embryo, take a sample. We can now freeze the embryo reliably and dependably with almost no detriment to the embryo.
Correct.
And then these little biopsies go to special labs. What do they do in these labs? Unpack this a little bit. So this is incredible technology.
So when it comes to the lab, in a small tube that, so all the cells, it's about 5 to 7 cells.
So just 4 or 5 cells is a microscopic sample.
It is very minute.
Minute sample.
Yeah. So it's like 4 or 5 small hair-like things.
This is microscopic. You cannot see this with the eye. So you get a little tube. You get a series of tubes, like on dry ice, and they come in cold. They're shipped in, let's say, to a central lab from all these different IVF clinics.
Yeah.
They get these samples. Yeah. Then what happens to these little vials?
Then the DNA is being extracted from there, and the DNA gets amplified. So
you can magnify and
so we are making few thousand copies of the DNA.
So you double it,
double it,
and you double that, and you double that, and then you double that, and all of a sudden the DNA of just the tiny bit of DNA,
Yeah.
all of a sudden is
Yeah.
is amplified millions of
Correct.
times, right?
So we have the copies then,
okay.
and then there are other that needs to be tagged with a different specific genes, which is specific for that particular chromosome.
You know what that's called, Anil? You know,
Yeah.
it's called barcoding.
It's about coding.
So they take this DNA.
Yeah, we put every chromosome.
And they chop it up
Chop
and
it up.
barcode it.
Yes.
All right, so now each of these little broken up segments has a little tag on either side. Then what do you do in those?
So once they get tagged, then it goes into the machine.
What is the machine?
Well, it's amplified process of DNA, and it goes, then some of those the nucleotides, which are
the things that make up the steps
make
that make
up
up
the
DNA.
It gets incorporated, and certain ions are released, and that ion is then registered. So it's a large spectrophotometer, what we can call it, and then it gets.
I'm going to explain this now for people.
Yeah.
Here's a cell phone, an iPhone here.
Yeah.
There are little chips in here.
Yes.
With megapixels, right? These tiny, tiny little cells. What this machine does, Anil, is it turns each little pixel into a test tube.
Yeah.
So you get millions and millions of data points.
Yeah.
That then go into a special computer.
Uh-huh.
And that computer does multiple parallel processing, blows my mind.
Correct.
And puts all these signals back together with the barcode.
Mm-hmm.
And poof, you get a readout. You get a read. What's called a call.
Yeah, it's a high level of computing, high levels of analysis, and it was only possible after the Human Genome Project, which mapped all 23 pairs of chromosomes. That the mapping is there, so we have a reference library, and then that the amplified DNA, the processed sample, was read against the genome.
The genome, what's basically normal with a little bit of
change.
So this has evolved in parallel with the world of genetics.
Yes.
So we've been able to borrow and share the technology. So it's the field of genetics, powerful computing, microchips.
Yes.
As all this has come together, we've been able to utilize it to advance reproduction, make reproduction more successful, more dependable, allow people to have babies in very difficult circumstances sometimes, despite difficult circumstances.
And also for the inherited genetic diseases.
That's the next thing. Tell me about that. So one problem an embryo can have is abnormal numbers of chromosomes, which are almost always fatal. There are diseases that run in families, aren't there, Anil?
Yes.
Horrible, devastating cancer syndromes.
Yes.
The list is thousands of diseases long. And those are due to actual specific mutations. There's an actual molecule in the DNA that's wrong, isn't it?
That is correct.
So what can we do about that, Anil?
This was not heard of. Earlier we cannot even think about people who
right.
It
was hit or miss.
Kids suffering, there's a balance translocation,
hemophilia, it goes on.
Mental retardation,
Tay-Sachs disease.
Tay-Sachs.
Horrible suffering.
Horrible. So now that if we know the genetic mutation, then the very highly specialized lab can generate the probes which mimics that particular mutation.
So you can find these mutations now, can't you?
Into the embryo, into those biopsy cells.
So you can find an embryo that's destined to have some horrible, deadly, miserable disease.
Correct.
Or you can find an embryo that is possibly free of this disease.
Absolutely.
So parents have, sometimes they come to me, they've had 1 or 2 children that have died miserably, and they just want to have a healthy kid. They just want to have a healthy child to raise and be disease free.
Yeah.
Whose children and their grandchildren, their great grandchildren can also be disease free.
Yeah.
Isn't that incredible?
It is incredible
that we can do that.
But
people.
again, as you know, that this is not 100%, but at least we have, uncovered all the stones.
Right.
But there are, like mosaic, the embryo can show one thing, but actually the baby turns out sometime.
Yes, so.
And it happens. So
right. So let's point out that we biopsy an embryo. And we can analyze the biopsy, but does the biopsy accurately reflect the embryo in the child that develops? And it's not 100% correlation.
Correct.
We do our best, and we can do pretty darn good.
It is.
And in the world of medicine, Anil, people need to understand there's statistical certainty, there's Six Sigma certainty, there's engineering certainty. Like when you drive over a bridge.
Yes.
An engineer can tell you, an architect can tell you, well, we put this much rebar in there and this much concrete, and I can guarantee that truck can drive across that bridge and it won't crumble, right? You can guarantee that kind of certainty. In medicine, biological certainty, it's a little lower bar. Every time you have surgery, I mean, I was in surgery all day today.
Yeah.
I mean, 1 in 100,000 people will die of anesthesia.
Yeah.
So there's these inherent risks in the life sciences.
And which is not in your control.
Right, it's not in our control. We do our best.
Yeah.
Driving a car, you don't wear even a seatbelt won't protect you 100%.
Sure.
Right. Yeah. So I think you bring up a real important point, Anil, that we give it 100% effort.
Yes.
The technology is probably better than 99% good. And then when we apply it to biology, there's some gray areas there.
Yeah.
But I think we can say for the vast majority of people, the vast majority of conditions, we can now provide answers and solutions where only just a few decades ago there were none.
Absolutely.
For people with absolutely no hope or virtually no hope.
Yeah.
That's incredible. Now, where do you see this going, Anil, in our lifetime?
I think, the next big thing coming is AI, artificial intelligence.
In what way?
To apply all this knowledge, all this data we are collecting in the lab is, right from when you give us egg in the lab to look for to fertilization, how the process of the cell division, how the embryo is dividing each day, each hour. When it's making a blastocyst.
Blastocyst is a day 5 mature embryo.
Day 5. I mean, the lab can grow embryo until day 5 to 6, maybe 7, but 6 is the optimal.
Okay.
That's how the lab, the current conditions, the media conditions can allow us to. After 7th day, it degenerates. So the AI, it's required, again, a collaboration of hundreds of labs to pour their data into this AI.
Okay.
And there are, some laboratories are collaborating and collecting all this data. And with this computer scientists, the data scientists, with
massively powerful computers.
So it can give us the tool to, we generate many embryos in the lab from the patient. On average 6 to 7 or maybe 10. And then we are analyzing those for genetic analysis, and then we have 4 or 5 good or normal PGD, genetically tested normal
So
embryo.
you can have a normal embryo with normal genetic testing that may still have other problems.
But it still be the
'Cause
30% of
right.
them,
'Cause
they
sometimes
don't
we
implant.
Sometimes we transfer a beautiful embryo, everything looks perfect, and we throw up our hands for some reason. It's
That
not
work.
working in
Yeah.
that patient, and
Correct.
sometimes it happens over and
So-
over. And we pull out our hair. Clearly, you've pulled out a lot of your hair over the years, and I'm certainly getting a lot more gray hairs.
Yeah.
So, what you're saying is that if
AI.
computers can watch this, they can take videos of the embryo development, and without preconditions. You see, the thing is, we're programmed to think, well, symmetry is good, or
Yeah.
a round cell is good.
Yeah.
There's things in our brain that we find
Mhm.
appropriate or attractive,
Yeah.
or we assume is good. The computer has no preconceptions.
No.
And what it's going to do is it's going to watch everything it can
Mhm.
and find out what is associated with success,
Mhm.
what is associated
Yeah.
with disease beyond what we can test now.
That is correct. I think that's what the AI is going to do in IVF field.
It's
And
going to
of
continue
course,
to
yeah.
fine tune. So instead of 86% success rates and whatnot, now we're going to start pushing into 90s.
Correct. It is. And, the fertility preservation is for the young women is like, it is now, if somebody is like 30, 31 and they haven't found the partner, or they're in a serious relationship, they immediately go to the IVF center to freeze their eggs.
That's right.
So
Young
there's
women.
awareness, there's fertility preservation,
Uh-huh.
not, for social reasons,
Right.
but it's there. The technology is there. For the guys, it's not that much a problem.
Right. So it's been easy. We've been able
It's
to freeze
easy.
sperm for decades.
For
It's easy to
decades,
freeze sperm. But their small cells are already dehydrated. They're
Correct.
made to freeze.
Yes.
Sperm is easy.
Yeah.
Just mix in some antifreeze, throw it in the freezer.
Yeah.
Eggs have been very difficult
Very
to freeze.
difficult.
It wasn't
It
maybe
is.
7 or 8 years ago.
Yeah.
This vitrification, these snap freezing technologies became available.
Yeah, it has revolutionized the whole industry, especially for donor eggs and
Yes.
for fertility preservation.
Let's talk about that, Anil. There have been some real advances the past few years, in part brought on by the COVID pandemic.
Mm-hmm.
Let me explain to our listeners about that. When we have a young woman, when a woman needs some eggs, she's run out of eggs, she's
Correct.
had cancer,
Uh-huh.
the woman has no eggs.
Yes.
We find a woman generally with her same characteristics, 5'2", eyes blue, brown hair, whatever.
Yes.
We would have to find this, and we would have to give her medicines to make eggs. We'd have to fly her in,
Correct.
stay in a hotel, rent a car, snowstorms, ice storms, all these logistics to get her in our lab,
Yes.
to get her eggs.
Yes.
But with COVID, the planes weren't flying. The
Yeah.
women couldn't travel.
Yeah.
So coincidentally, with the pandemic making donor eggs so hard to get,
Mm-hmm.
the freezing technology came up to speed.
Yeah.
Right? Developed in part, at least a lot of it done in Japan, so that women can freeze their eggs and deposit them in an egg bank in the same way we have been freezing sperm for sperm banks for years.
Yes.
And now, instead of having to fly a woman in or whatnot, we just go online. A patient can go online. Yes. There's 5'2", eyes are blue, brown hair.
Yeah.
Order them, and they can come shipped frozen eggs right to our door. Isn't that amazing? Yeah. So COVID has really pushed us in that way. Mm-hmm. And then we're doing almost all exclusively frozen donor eggs nowadays.
Yeah. Yes. I think it's very easy for the recipient just to match the characteristic, pick up this thing.
Yeah, FedEx is a lot more reliable than planes.
Yeah.
I want to talk about how difficult plane flights have been the past few years. Yeah, so that's been a huge advancement as well. So now we can get frozen eggs from an egg bank. Mm-hmm. Frozen sperm. In fact, I had a couple just recently. He had a sperm problem. She had an egg problem. She's pregnant now from an embryo made for the donor egg and donor sperm.
Yeah.
But it's in her tummy.
Yeah.
They are thrilled.
Yeah.
She's gonna have a beautiful baby.
Yeah.
No one's gonna know it was done because the baby's gonna come out looking pretty much like them.
Yeah. Yeah.
And problem, I don't want to say solved, but problem addressed.
Address. Yeah.
Addressed.
The dream fulfilled.
So let's go in. Maybe this will be beyond our lifetimes, Anil. Let's go into the world of science fiction now and talk about germ cells. What are your thoughts? Now, already, I believe in mice, you can take a germ cell from a mouse. I think from their bone marrow.
From the skin.
From the skin.
Yeah. They can make
grow it into a sperm or grow them into eggs.
Yeah.
Whoa! Tell me more about that, please.
It is still very early stage. This is experimental. A lot of work is being done, and success will come eventually once they, standardize, streamline the technique. So it will, it will be for years to come to apply clinically, those technology.
Now, have they done it in mice?
Yeah, they have.
I think they've done it in mice.
Yeah.
They've made sperm from a germ cell. They've made an egg from a germ cell. They fertilize, they make an embryo, and those embryos will make pups.
Yes. So, yeah, few experiments are successful, and I think we're waiting for more and more.
Right, they're going to have to follow them down for many generations.
Yeah, it is.
Things could come out in future generations and things that you don't anticipate.
Yeah, we can also freeze ovaries. That's another for the cancer patients.
Right.
And then
that's been done for a while.
It is, some specialized centers, they do that, in this country.
So it is not it's not complete fiction, but it is not out of the realm of possibility.
Correct.
That, for example, a child is born, and they can take some blood cells from the placenta or the umbilical cord or something, and freeze them. And later in life, if that individual has disease or problem making sperm, the woman has a problem with her eggs for whatever reason, cancer, illness, whatever, that they could take those stem cells, thaw them out, mix them with special chemicals, hormones, and direct them to grow into eggs or sperm and restore their fertility through something related to in vitro fertilization.
Yeah.
That's amazing.
Imagination was, we can imagine. It's going to come. It's going to come. The other thing I think you may ask me, what is our biggest problem, or
Please, this isn't all unicorns and rainbows. What are some problems, Anil?
The problem, I think, the dilemma, or we are generating a lot of embryos, and we are freezing it.
Right.
Excess embryos, we freeze them, we store them. So the lab, we have to keep them in a suspended state so that we can use it.
Right.
But it's not only in US, but throughout the world. This is a huge problem of those excess stored embryos, and the family don't need them,
or they get divorced.
Like
we send out letters, Anil, to a couple. Gee, we haven't heard from you in a while. Right? It costs a certain amount of money to keep them stored. We say you haven't sent a check in a while. We say, where are you? They don't respond. They've disappeared.
Abandoned.
They're divorced.
Yeah. So
what do you do with the embryos?
And that is really it is patient's responsibility. And it's like your money in the bank. You have stored those embryos with us or with any lab.
Yeah, because we're the steward. They're not our embryos.
No,
they are a special. Usually they're married. It's a special marital asset.
Yes,
it's not mine.
Yeah. So
it's yours, but you've abandoned them now. Sometimes
it's a huge burden or responsibility or dilemma what to do with abandoned embryos.
Sure.
I mean, I have known. I mean, where I was at George Washington in 1997 to 2013, we had embryos from 1986, 88.
Right.
Were still there. The risk management committee of the university or of any other lab will not allow us to discard, and we never ever discard any embryos which are abandoned. We still have those, and
and now they get shipped. Now they've got some commercial repositories.
It is,
there's several big ones around the country, Texas, Minnesota. I don't know exactly where they are, and they're just growing. And there's like 500,000 embryos in these various storage facilities, long-term storage facilities.
Yeah, and the errors can occur in the lab where we put them in under liquid nitrogen. It is being monitored 24/7, but something beyond human control can happen, and we can lose embryos.
Sure.
A tank, and it has happened.
Sure. There's a very famous picture. It was on the cover of Fertility and Sterility of people in boots in Hurricane Katrina when New Orleans was flooded, and it shows these people, these two guys, I think, holding one of these big flasks. They're called Dewar flasks. Essentially, they're big thermoses. They're like as big as an R2D2 unit, and it shows them carrying them out through the floodwaters.
Let me give you another example of what happened in Ukraine war when Russia invaded Ukraine. One of the largest donor egg supplier, they had thousands and thousands of embryos, and they have to rent a truck and ship it out to Poland.
To Poland. So Ukraine, I know Ukraine is essentially a Caucasian country, and was a good source for eggs. It was cheaper there.
It was a shortage now in this country.
Yeah, so there were several well-established facilities there for donor eggs, embryos, even surrogates. So a war comes in. What happens if a missile explodes on the top of your lab? Kaput.
Tens of thousands embryos were. So we do take care. We
do our best. I have contingencies for hurricanes, floods, tornadoes, earthquakes. All in binders. I mean, this is all, and that's part of your job.
That is.
You take care of my lab.
Yeah, that is true. I mean, it is. It's a nightmare for embryologists. Yeah. It is one of the we just are walking on the eggshell with this. So and then again the other thing is the identification or the chain of custody, labeling embryos. Something can happen in the lab. The human error can occur. There are some examples, but 99% time, the embryologists, they do a pretty good work.
Yeah, we have systems in place, or everything's coded.
You got to have a system in place. You got to have witnessing.
There should not be error. However, if you have a bad, it kind of comes like gun safety. If you have a determined person, it's hard to completely stop all acts of violence. So if you had an inside person in the lab, bent on destruction or bent on malfeasance, I mean that's true.
Somebody is out, somebody's mad. And we see that all the time.
Well, not in IVF, but in the world. In the world, you see this. Sure.
Crazy people.
So this is the real world, and there are real world problems. Even in IVF, nothing's going to be perfect. But I'm going to say this again: that we have safeguards, best practices, protocols that we follow. We're inspected, and those types of errors really shouldn't happen. But acts of God, I think it's called force majeure.
Yes.
War is considered a force majeure. Can happen. Wow. I'm going to take a risk and go even further into science fiction. We cannot do this now, but gene editing
Uh-huh.
is being developed.
Mhm.
The ability, let's say we have an embryo with this horrible genetic condition.
Correct.
We would choose not to, we would keep it frozen nowadays. We would choose not to transfer it. A day may come where we could thaw out that embryo and treat that embryo and actually repair that DNA disease and fix the disease.
Mhm.
In fact, people hear of CRISPR, and CRISPR is probably just the first of many of these editing genes and enzyme complexes. Better ones, I'm sure, will be coming.
So it's not fictional anymore.
It's not fictional anymore.
It was the experiments were done.
Yeah.
The embryos were edited.
In China.
In China. Remember that was 3 years back, and the whole community was shocked with this. And
there was quite an uproar and pushback.
They disowned the person.
I think he's in jail in China.
He's in jail in China. So yes, it's just like playing with the fire.
Yeah.
And your imagination can really go wild. I mean, you can do the genetic editing. You can create monster.
Well, that's where I was afraid to go. But I'm just going to mention this because I wanted to make it clear we cannot do what I'm about to say.
Society will definitely, and that's where we need the control.
Yes, and we've got very strong ethical rules and regulations against this stuff.
Yes,
but theoretically, if we can start repairing problems, we've been able to knock out genes in animal experiments for many years. We may be able to start to knock in genes.
Yes.
Now you've got an embryo. Maybe you can grow taller. Maybe you can grow it stronger. Maybe you can grow it faster. Maybe you can grow it a little dumber.
Yes.
So it will follow instructions better.
Yeah.
And it's scary and exciting to think where this may go in hundreds of years.
Yeah.
Maybe it'll be sooner than that. But this is going to open up a whole new world of ethical dilemmas.
Yes.
This is human evolution magnified multiple orders of magnitude because we're now evolving ourselves.
Yes.
And we will not see this in our lifetimes.
I don't want to see it.
I don't want to see it. I'd rather not see it. Thank you very much. But that eventually may come. And we need to start at least thinking about it and preparing for it and keeping our ethical guardrails up.
It has
and having our standards of care.
There should be rules and regulations and just controlling this experiments which are really
many good things may come from it because maybe we don't have to make so many embryos now. Maybe in the future you could make just one embryo as needed.
The AI
is disease free. So some incredible things may come that may solve or begin to work around some of the problems we're experiencing right now.
So the future is bright.
I think the future is very bright.
Very bright. And and here I want to say that the patients, the couple, they go unimaginable journey on this.
Yeah.
Socially, financially, physically, to achieve their dream.
Yes.
And we are fortunate to help them in this journey, you and I. More you than
no, it's
me.
equal. No, we're all partners. I couldn't do it without you.
Yeah. And that's what makes me going even after 40 years in this business of research and then clinical application and then helping out. I'm very humble to, and it's a privilege.
It is.
To help these patients, and their trust is unimaginable.
It really is. Well, I'm gonna let it end there, Anil. We've had incredible. They're not over with yet, but we're starting to get to the end of our careers. You and I have witnessed an amazing development
Yes.
in medicine, and technology,
Mhm.
our ability to help people with infertility is otherwise insurmountable. We've worked with incredible people. It's been a hell of a run, Anil,
It is.
and I hope we have another number of years where we continue to see these advancements that we've kind of started to flesh out here, and who knows, other things may surprise us.
Yeah. Yes. Surprise for good surprise.
Good surprise.
Yeah.
Well, thank you for all your years helping us, Anil. Hopefully, we'll have many more years of success. And what a pleasure it has been talking to you today about the development and evolution of IVF.
Same here. Thank you so
Thank
much
you
for
so
having
much,
me.
Anil. What a pleasure.